the last of our rapid session presentations, we welcome WorkSafe Victoria Senior Process Safety Analyst, Ross Boots. Now, many of our Victorian MHF sites may recognise Ross, having been with WorkSafe Victoria for more than 20 years. He's also well regarded nationally within the industry. So we'd like to welcome Ross to the forum. Ross's presentation will focus on acute toxicity criteria available to major hazard facilities. So Ross, I'll go straight to you.
Welcome everyone. I'm giving a presentation on acute toxicity criteria because this really reflects a bit of a journey of myself. I'll first make an acknowledgement of the original owners of this land, their elders past, present and emerging. And I'd also like to acknowledge my local Pangerong mob who where I drafted this presentation. Now, ethanol is not really in line with WorkSafe's values, but I find it a very useful tool to remind people what the difference is between acute and chronic toxicity, and you know, the very subtle changes on reaction times that cause our blood alcohol limits for driving through to quite serious health effects. So this is a quick overview of toxicity criteria. I'll go through some of the various methods that are used. This is not exhaustive, but probably the more common ones. The most critical real thing for me to say is this is not a definitive opinion from WorkSafe Victoria. It is a conversation starter and a part of the consultation process for us to travel down in the future. So a few points with this graph. This is a typical toxicity curve, sigmoidal type response. A few interesting things here. The key phrase is the dose makes the poison. Going back to the ethanol, there's a big difference between having one glass of red wine at dinner and necking a bottle of scotch, and obviously the outcomes are quite different. And we have a concept of threshold where there is little or no response. And the other point that we need to remember is a healthy worker effect. So if workers are able to get out of bed in the morning, get themselves to work and work a day, they are far healthier than a certain proportion of the population. And we need to remember that when we're looking at toxicity effects. So without further ado, I'll jump into some of the different criteria that I reviewed. The first are the emergency response procedure guides from the American Industrial Hygiene Association. So these, in summary, are tools to assess the adequacy of accident prevention and emergency response plans. They've got a couple of advantages. They've got 3 different levels. So you have a 1, 2 and 3 level for a different level of response. They are well recognised. They are the most common I've seen in various safety cases, and they've been available for a long time, and they are not overly conservative, as the AIHA points out. There are several disadvantages though. They're really only designed for emergency response, and they only have a single time point. Now you can do various adaptations for single time points for different doses, but it does vary with the metabolism of the chemical of concern. And there is some concern as to whether it is actually conservative enough. I'll explain this a bit further down the track. Probably the next most common one we see is from the Purple Book. This was originally produced by the Committee for the Prevention of Disasters in Holland. And in my summary, their methods to calculate the risk due to dangerous substances in the Netherlands using models and data available. So it was specifically originally developed for the Netherlands, but it has been used worldwide, as we all know. A couple of advantages. It's part of a comprehensive QRA process, so it can be integrated into other risks, such as fire and explosion. They are well recognised, and the policy is widely available, and it does use the recognised probit analysis for coming up with answers to the probability of effects. However, on my review, it has several disadvantages. It's designed for consistent QRAs rather than actual results. By way of example, the sigmoidal curve I put up earlier, they've actually made that into a straight line, so it was more consistent. However, that doesn't actually reflect your typical toxicity that happens in real life. There's no time points less than 30 minutes. And obviously, if you're doing modelling, some gas clouds and the like could take quite a bit less than 30 minutes. More importantly, it has not been updated since 1999 as far as I can find. I'm happy to be corrected on that. And it is really only for high consequences. So it talks about fatalities. And obviously we want to know a lot more about what's happening before we get fatalities. And the other disadvantage is probit analysis, because it was quite a lot of work I found to try and analyse and probit analysis, and it made my head ache too much. The next criteria I reviewed was slots and slods. Now, they're produced by the Health and Safety Executive in UK, and they're the exposure conditions which would produce a particular level of toxicity in the general population. So this is for general population. Now, there's a couple of really strong advantages with these two. You've got two levels. Firstly, the specified level of toxicity, which I've spelt out the actual details here because it's important that we get that. So this is a level of toxicity where it causes severe distress to almost everyone. So that's pretty high. Substantial numbers of people will require medical attention. Some people will be seriously injured. And more importantly, particularly in the public, some highly susceptible people will possibly be killed. SLOT was originally developed from the 1% fatality rate of the exposed population, but other influences were also used as well. But obviously, that's a very high level. More importantly, the significant likelihood of death is even higher. That's based on a lethal concentration of 50% by inhalation in animals and hence humans. So they're very high levels. Results in curves, which can be used for a wide range of scenarios. That's very helpful. So you can pick a time range appropriate for your methodology that you use, and it's also available for a wide range of substances. And those curves actually reflect the metabolism, so they are different shaped curves for the different toxicity mechanisms. Some of the disadvantages, though, it's really only for the very high end of the consequences. So it's really for land use planning and also disaster planning. It's not really for major hazards functionality. One of the big movers in recent times has been the acute exposure guidelines. They were developed by the National Academy of Science in USA for the US EPA, and they are exposure levels below which adverse health effects are not likely to occur for the general public. They are for emergency planning. So it's similar to others. We've got 3 levels. But, and that's really good. So the first level is transient and reversible effects. That's good. Level 2 are irreversible or serious or impaired escape. And level 3 are life-threatening adverse health effects or death possible. So that's covers a fair span. So again, like the slots and slot, they result in curves that can be used for a wide range of scenarios. They are available for a very wide range of substances, and they are subject to a very rigorous research program. The National Academy of Sciences have done an excellent job of basically producing a mini thesis for each chemical, and so it is very rigorous research, so it's well based. The only disadvantage really is it's more for the lower end of the consequences, especially the 1 and the 2. Level 3 is at the sort of the threshold of serious effects. Now, the next toxicity criteria I reviewed was the immediately dangerous to life and health. They're produced by NIOSH, part of the Centre for Disease Control, and one of the excellent research organisations and standard-setting bodies in the USA. So, in summary, these are toxicity criteria to ensure the worker can escape from a given contaminated environment in the event of a failure of the respiratory protection equipment. And this is where it started off. It originally started off as, where do you need to actually have self-contained breathing apparatus? And I won't read all the rest because it goes on and on. So what are the advantages? Well, they've got a very good reputation, being produced by NIOSH. Again, a wide range of substances. It fits well between the low and the high level consequences and allows for acute effects affecting escape. A lot of the other toxicity criteria doesn't allow for where the actual effect of the toxicity makes more exposure likely. So this is one of the big advantages of the IDLHs, and the methodology roughly aligns with the AEGLs. One of the disadvantages is really it's only a single point for 30 minutes. Now, you could modify that, but you'd again have to do a fairly strong review to make sure that toxicity aligns with the metabolism. So it could be a bit tricky. And the last criteria I looked at were the short-term exposure levels and the ceiling levels. These were originally published by the ACGIH, and these are to prevent rapidly occurring adverse health effects. So these are for workers and not for the general public. So some of the advantages, they're well researched and documented. Certainly not up to the thesis level for the National Academy of Standards, but the documentation of TLVs published by the ACGH are well known, and they are the basis for most Australian exposure standards, but naturally WorkSafe, Safe Work Australia and various bodies review these and then incorporated those into our national exposure standards. It reflects the worker response to the acute effects, and it covers a good range of substances. It is designed for routine exposures, not for emergency planning or disaster planning. It's for the day-to-day exposures. So what I did is I've drawn up a number of charts in Excel comparing the different criteria. Here's an example for ammonia. Now, we all know ammonia is a strong irritant, and so in particular of interest is we have the immediately dangerous to life and health, quite low, almost down to the AEGL2 level, because if it's a strong irritant, it will inhibit your ability to escape or inhibit your ability to put on your self-contained breathing apparatus. So that's why that is way down there. And we've got significant likelihood of death right up here. So at 60 minutes, just over 4,000 parts per million, 50% of people will be dead, basically, if they're unprotected. Slots are here, and again, that's a lower level. AGL3, so this is where the National Academy of Science says more of a threshold for a fatality. So there is a difference between slots and AGL3s. I think AGL3s are probably a bit more conservative, but certainly the amount of research you see behind them, they're probably a better option. And AGL2, which is the threshold for being temporarily affected. And then way down at a very low point is the STEL. By way of comparison, hydrogen sulfide, as we know, it is not a strong irritant. In fact, that's one of the reasons why it's so dangerous, because people don't realise they've been exposed to it. We have the ERPG 1, 2, and 3 along here. So that's 3. So that's the quite serious effects. And the ideal H is basically half of that. But also, interestingly, because it is not irritant, it's actually, the ideal H is actually quite a bit higher than the AGL3. One of the reasons for that is also the healthy worker effect, because ideal H's are for workers, and EGLs are for the general populace. And if you've already got a compromised lung capacity, the hydrogen sulfide is going to have a bigger effect. And then we have our STEL, it's called up in our legislation, 15 part per million. So there is quite a variation between the different toxicity criteria for the different substances. So what do we do about that? Well, it's a good question. This is my starting opinion, and I'm happy to have a good discussion about this. If you're going to assess the effectiveness of your controls, we have to go back to the compliance with the regulations. So that goes to the exposure standards. So if there is a ceiling or a STEL, you should make sure that your workers are not being exposed above that level. If there's not a ceiling or a STEL, the general rule of thumb is if you have any exposures above 5 times the 8-hour average, that shows that your process is not under control, and you should think about seriously getting better controls using the hierarchy of control, and also instituting better monitoring to make sure you characterise those releases that are causing the problem. For incident reporting, again, this is for compliance to the regulations, but our regulations don't really provide any detail as to what level it should be. So again, a starting point I consider would be, it should be either the IDLH or the AEGL3, whichever is lower. Now, obviously, there will need to be a margin, something in there, because remember, we've got those error bars on the curves. And the other issue is the error bars hardly ever appear except in the original research. So, but I think this is a good point to start as far as if people could have been exposed to the IDLH, well, it should be reported to your regulator. What about emergency planning? Well, obviously, this needs to be discussed a lot more with the experts. But I do know the general view in Victoria's muster points and staging areas should be at least below the AEGL2 level. So that's the temporary discomfort. And if that's not, if you don't have an AEGL2, perhaps we should think about the ERPG2 level. If you're trying to work out where you need to have your responders in self-containing breathing apparatus, again, it would be any time it's indicated where you might have, not will have, but might have exposure above the IDLH or the AEGL3, whichever is the lower of those two. Where you might have evacuations and shelter in place, and in fact, if you think about it, people should be sheltering in place and not wandering around the place at the higher levels. So I would say you have to have shelter in place if you're at the same as a self-contained breathing apparatus, because we don't want people outside trying to evacuate whilst at those high levels. And to make the options for public evacuations or shelter in place, well, that should be similar to the muster points. Land use planning becomes a bit tricky. Now, we're in the process of having a sort of a banding approach for the inner planning zone and the outer planning zones here in Victoria. The inner planning zones are really where we don't want any significant high density population and only low density working population. My first thought, oh, well, that slots, or HSC is very strong on land use planning. Slots, now, I think it appears way too high to me, and maybe with excellent emergency response, well, we know how. I wouldn't rely on that either. So maybe the AEGL3 level might be something for the inner zone. Again, we need to have a lot of discussions on this area. For the outer planning zones, well, I'm thinking the AEGL2 level is probably something appropriate because it looks after population and we have only, temporary effects for the exposed population. And that's a very quick rundown of my presentation, and naturally very happy to receive any questions now or comments via email or other means. Thank you.
Thank you so much, Ross, for that presentation. I do have a couple of questions waiting here, so I'll just get you to answer those quickly, if that's okay. First off, what is the significance of IDLH versus SLOD?
Okay, IDLH is the critical thing there is it's a threshold for where people might be seriously affected and the effect of the toxin will affect your ability to escape. While SLOD is basically significant likelihood of death, it's basically 50% of the population, exposed population, will be dead. So it's disaster planning, it's BOPAL. It's, I hate to say it, but, working out how many body bags you might need. That's how extreme it is. So, yes.
Oh, well, thank you for that explanation. And I've just got one other question here. Which of the toxic criteria do you recommend MHF operators use as a basis for impairment criteria when assessing the exposure of A, workers at an MFH, and B, off-site community?
Well, I would be looking for the off-site community. I'd be looking at the AEGL2s as far as impairment goes, because that's based on a general population. Again, we're going to have to think about this. This is the start of a conversation. I would think IDLHs for the impairment inside for your workers, but you need to have a think about how much do you need a margin of error there, because you've got to remember that very first curve I put up, there's all those error bars that nobody ever uses ever again after once it's been published. So we need to allow for the error bars because we're talking about people.
Thank you again. So, ladies and gentlemen, that completes our rapid session series.